Hey guys, in this lesson we would understand how to write down trigonometric equations when we are given the transformations or when we are given the graphs of the transformed trigonometric functions. Let's take the first example where we are given the description of the transformations. The question says the graph of fx equal to sine x, that is the parent function, has a period of 10, amplitude of 2 over 5, and equation of axis is 1 over 15. What is the transformed equation? In order to write down the equation, we would first write down the general transformed equation for sine function. And we have that as y is equal to a sine k x minus d plus c. We are given the amplitude of 2 over 5. That means the a value is going to be equal to 2 over 5. We're given equation of axis as 1 over 15. That means c value is 1 over 15. Time period is given to us as 10. We would be using this time period to get our k value, and because time period is 2 pi by k, therefore k value would be equal to 2 pi by time period. So in order to get the k value, we would do 2 pi divided by time period, and since time period is 10, we divide it and write it down in lowest terms. We get pi over 5. Because nothing is described about the phase shift, that means d value is going to be equal to 0. Now we would use all of these transformation parameters to fill in a, k, d, and c in the transformed equation, and that would give us the final answer for this particular problem. So we have y is equal to 2 over 5, sine k value is pi over 5, x minus d is 0, plus c is 1 over 15. So the final answer is y is 2 over 5 sine pi by 5x plus 1 by 15. And this is our final answer for this particular question. Next question is to write two sinusoidal equations in y equal to sine x form and y equal to cosine x form for the following graphs. And the graphs are, so let's say we are given this graph and we are asked to write down two sinusoidal equations that represent this graph. One sinusoidal equation should be in the form of sine x and one sinusoidal equation should be in the form of cosine x. Then the steps that we have to follow is, the first step is take the max value, add it to the min value and divide by 2 to get the c value. And c is going to be the equation of axes. We are given max as 1 and min as -1. So in this particular example, max is 1, min is -1, divide by 2. 1 minus 1 is 0, divided by 2 is 0. So the c value we have in this particular example is 0. Second step is take the max value, subtract it with the min value and divide by 2, and this would give us a value. In this example, max is 1 minus min is -1, divide by 2. So this gives us 1 plus 1 is 2 over 2, which is equal to 1. Therefore, amplitude we have for this example is 1. Third step is find the time period from the graph and use it to get k value. So how do we get the time period is, we pick any one point as a start point. Let's say this is the start point, and now we would see where that point occurs again. And we notice that point occurs here again. If we pick this as the start point, then this would occur here again at this point. If we pick this as the start point, then we would see this occurring again at this point. The best way to get the time period is basically the x value between 2 max or between 2 min is going to give us the time period. So we have these two maxes here. The x value between the 2 max is, because this point is going to be 0 and this is 1. So the x value is 1. Therefore, the time period in this particular example is 1. So if the units are seconds, we can write on time period as 1 second. Now we would use this time period to get the k value, and k formula is 2 pi divided by time period. So 2 pi divided by 1 is 2 pi itself. Now we've got our c, we've got our a, we've got the k value. All we need is the phase shift, that is d value, because in order to write down transformed equation, we need a, k, d, and c. And that is step number 4, is to determine the d value. Now for finding the d value, because d is the phase shift, we need to know the parent function sine and cosine graphs for both a positive and a negative. These two are the sine function graphs. So the first one represents when a is positive. Second is the graph of sine function when a is negative. These two represent the cosine function graph, where the first one represents when a is positive and the second one represents when a is negative. Now we would match these parent sine and cosine function graphs with the given question graph and see what it looks like. Let's say if we consider this as a start point for our graph, so one full cycle will be represented by this white part of the graph, and that looks exactly like cosine x graph with a positive. So if the start point of the parent function graph and the start point of the graph that we are writing equation for is exactly at the same position, then the phase shift for that particular function is 0. That means if we consider this as the start point, then the phase shift for cosine function equation will be 0. Therefore, for this example, we say d is 0 if start point is the y-intercept, and this would give us cosine x graph. Because we also have to use the same graph to write down the sine x function equation, we notice here that the sine graph starts at the intersection of y-axis and the equation of axes. We always have to find out the intersection point of the y-axis and the equation of axes in order to determine the sine x equation. So we notice that the parent sine function graphs, they start at the intersection of y-axis and the equation of axes, be it when a is positive or a is negative. Now we would locate this 0 point in the given question graph. We notice that the 0 point, that is the equation of axes meeting the graph, or we can say x-intercept, or we can say the 0 point, is at this point and at this point. If we consider this as the start point, then the phase shift is everything from the y-axis to that start point. So this is going to be the phase shift. And if we consider this as the start point, then the phase shift is going to be from the y-axis to this point. Now both of these points are 0 points. What's the difference between the equations when we take start point as this and when we take start point as this? We notice when we take the start point as the blue point, the graph is going from 0 point downwards, whereas for the green point, the graph is going upwards. We notice here that the graph from the 0 point goes upwards when a is positive, and the graph from 0 point goes downwards when a value is negative. So if phase shift is d equal to 0.25, because that's the d value going to be, because d is always the x value from the y-axis to that point. So if d is 0.25, then we will be able to write down y is equal to sine x function graph with a negative. Whereas if we take 0.75 as the phase shift, so if d is 0.75, then the equation would be equal to y is equal to sine x with a positive a. Now piling all these steps together, we got the c value as 0, we got a value as 1, k value as 2 pi. If we consider d as 0, then the final equation would be in terms of cosine x. So it would be a cos kx minus d plus c. A is 1, cos k is 2 pi, x minus 0 plus 0. If we simplify this, we would be able to get cosine 2 pi x. And this is what is going to describe the equation of the graph in terms of cosine function. Second scenario, c, a, and k for a particular graph will never change. So c we determined was 0. A was 1, k was 2 pi. Now if d is considered 0.75, then the equation is going to be y is equal to a sine kx minus d plus c. A value is 1, sine k value is 2 pi, x minus 0.75 plus 0, and this would give us sine 2 pi x minus 0.75, and that's the final answer for y is equal to sine x equation for the given graph in terms of sine function. If we consider c0, a1, k is 2 pi, and now if d is taken as 0.25, then the transformed equation is still sine x function equation. However, it will be negative a sine kx minus d plus c. Now when we sub in all the values, we get negative 1 sine k is 2 pi x minus 0.25 plus 0. Therefore, the final answer is negative sine 2 pi x minus 0.25 is what is going to represent another sine equation for the same graph. So we wrote two sine equations and one cosine equation for the same graph. We were asked to write down just one sine and one cosine equation. So out of these three equations, this is definitely part of the answer. Out of the green and the blue equation, any one could be the answer. Just remember, for a given graph, the transform trigonometric equations can be written in multiple ways, in fact in infinite ways. The only difference that would lie is in the d value that would change the parent function of the graph. A, k, and c would always stay the same for the given graph. Now let's say we have to write down sine and cosine equation for this graph. Step 1 is to find the c value. C is max plus min divided by 2. Max is at 3. Min we notice is at negative 1. So 3 plus negative 1 divided by 2 is equal to 2 over 2, which is 1. Second is to find out the a value, that is max minus min divided by 2. Max is 3 minus min divided by 2, and this would give us 3 plus 1, 4 by 2, which is equal to 2. Third step is to get the k value, when k is 2 pi divided by time period. Time period we know is the distance on the x-axis between the two maximas. We can easily locate the two maximas on this graph. So the time period is going to be, this point is negative pi by 2 because it's halfway between 0 and negative pi. And this point is halfway between 3 pi and 4 pi. So it is 3.5 pi. So we can say this is 0.5 pi and this is 3.5 pi. Distance from 0 to 3.5 pi is 3.5 pi plus 0.5 pi. So this total distance is going to be 4 pi. Therefore, the time period is going to be 4 pi. Pi gets cancelled. We are left with 1 over 2. And that's the k value. Now the phase shift is going to be different if we consider it as a parent sine function or if we consider it as a parent cosine function graph transformation. So we know the parent cosine with a positive looks like this. So this is y is positive cos x graph, and we know y is positive cos x graph starts at the maxima point. So if we take this as the start point, then the phase shift is the distance between the y-axis and the start point. So this is our start point. So the phase shift is going to be negative pi by 2, and the equation would be y is equal to a cos kx minus d plus c. A is 2 cos, k value is 1 by 2, x minus d is negative pi by 2, which makes it a plus pi by 2 inside the bracket, plus c is 1. So this is one equation in terms of cosine that would represent this graph. Now we know c value is 1, so the equation of axes is going to be at 1, that is this one. To find out the sine start point, we need to locate where does the graph intersect at the equation of axes. So that is called the 0 point. Let's say we consider this as the start point for sine function, because sine starts at the 0 point. Cosine starts at the max or the min point. So if we're considering the start point for sine as the 0 point and the graph is moving downwards, that is like this, this means this is the graph of negative sine x parent function. So if this is the start point, phase shift is going to be positive pi by 2. So if d is positive pi by 2, the equation is going to be y equal to minus a sine kx minus d plus c. A value is 2, so it's negative 2. Sine k is half. X minus d is, because d is pi by 2, so it becomes x minus pi by 2 plus 1. And this is how we represent this graph using sine function. And this is finally how we get the two equations, one in the cosine function form and one in sine function form for a given transformed trigonometric function graph.